complicated equations learned a little bit more simply. So let's use this example of patients that developed silicosis, and our risk is going to be sandblasting exposure. So I'm going to make up some numbers really quick. So we'll say 80 in this box. Then we have 20, 100, 40, 70. That adds up to 110. 80 plus 40 is 120. 20 plus 70 is going to be 90. 100 and 110 is going to give us 210. Okay, so we can also label A, B, C, D, and that's going to help us with some of these equations. So let's first look at our point prevalence of silicosis itself. So if I'm going to look at the point prevalence, I don't care about what I'm exposed to. I just want to know the total people with silicosis compared with the total people in the study or in the sample. So our point prevalence of our silicosis is going to be the total with silicosis divided by our total in our sample. So for us, that gives us 120 over 210. Okay. So we're going to look at what this sandblasting might do and might be a risk to developing silicosis. So our risk with exposure is going to be right here. That's where I like to write it. That is going to be our 80 over our total of 100. So that's going to be 80. That means that we developed silicosis and we did have a sandblasting exposure over the total number of people that had silicosis. Or the total number of people, the total number of people that had that sandblasting exposure, that risk, but it doesn't equal the number that had silicosis. It's equaling that total number of people with or without silicosis but had that exposure. So 80 over 100. Okay, our risk without exposure is going to equal our no exposure, 40, with silicosis, over our total number of people that were not exposed to our sandblasting. So we're going to have 40 over 110. Okay, so that is our risk without exposure. You may be asked what the relative risk is, or RR. So our relative risk is going to be our risk of exposure over what our risk of unexposure. Or our risk without exposure. So if we use our example, that's going to be our 80 over 100 over 40 over 110. So if we do the math, that's going to add to 2.2. So if it is greater than 1, it is going to mean that that exposure that we were measuring, that sandblasting, is going to be harmful. If that the relative risk was less than 1, the exposure was not harmful. If it equaled 1, that means the risk of exposure and unexposure are the same. So now let's look at absolute risk. Our absolute risk is also called our risk difference, and it's the measure of our risk of exposure minus our risk of that silicosis with non-exposure. Okay, so that one is going to be that 80 over 100 minus our 40 over 110. So and that is going to give us 0.4. So if something is greater than 0, that means the exposure is a harmful risk difference. Something else that you may be asked would be the number needed to harm. So that's going to be our NNH. So our number needed to harm is going to be actually that 1 over that absolute risk or risk difference that we just calculated. So that's going to be our 1 over that risk of exposure with exposure minus the risk without exposure. Okay, so this would equal 1 over 0.4, which is going to equal 2.5. So 2.5 many more people that were exposed to sandblasting, only one of these people are going to develop silicosis. It takes 2.5 more people with exposure to develop silicosis. Our last thing that we need to know is our odds ratio, or OR. That is where these letters come into play. So that is going to be our A times D over B times C. So in our example, that's going to be 80 times 70 over 20 times 40. And that is our odds ratio. Okay. So this is talking about exposures and risk to developing a disease.